Hello, welcome back again to our YouTube channel Wi-Fi Tech Lab. So we have a video continuation from the previous one that we uploaded about two labs, local area network 1 on our left hand side and also local area network 2 on our right hand side. If you pay attention, on our local area network 1 we have a network ID that belongs to class C 192.168.1.0/24. We have assigned static IP addresses on the left hand side, and then on our right hand side, if you pay attention, we have a network ID of class B 172.16.6.0/16, and then we have configured a DHCP server to release the IP addresses to client computers. There is a DHCP pool that is configured on the bare metal server, and also on the DNS server we have created the record. Okay, let me just double click or click on one of the PCs in here so that everyone will be able to see what I'm talking about. So I just click on that PC or PC5. I will just go to its network interface card to see the IP addresses. So there are two modes. So we have a DHCP mode and then we have a static. As we have mentioned it, that on our right hand side lab, all of these devices, they have obtained the IP addresses, or they are leased with an IP address from a DHCP server. So they have this IP addressing, right? All of them, they have the same configuration. But on our today's topic, or our today's continuation from the same video that we uploaded, we will be talking more about something called Duplex with its Duplex modes, and then we're also going to talk about speed, and then we're going to talk about MTU. We're going to also talk about giants and runs. Okay, all right. Now the question arises, what is a duplex? Well, this is a point-to-point system which is used between the two devices on the network for the sake of the direction, right? So what do I mean by that? There are three modes under duplex. We have a half duplex, and then we have a full duplex, and then we have auto negotiation modes. Half duplex simple means that if we're willing to communicate two devices, PC0 and PC1, or directly connected to the switch, PC1 can be able to send the data, can be able to send the packet across to PC1. From PC0 can send the packet to PC1, and then it can also be able to receive while it's sending something out, right? That means it's a full duplex, right? It's a bi-directional communication. And then on half-plex mode, which means that one device can be able to send something, and then once that packet reach the destination, then the other device can be able to send. All right, now what about the MTU? Maybe before we touched upon the MTU, let's just demonstrate with the lab on the left hand side and see exactly where do we find the settings to configure these duplex modes and also the speed. All right, so we are on the switch currently on the CLI. This is the command line interface of this switch. All right, as we have mentioned it, that by default the switch is not enabled, so we need to type in the command enable. Okay, because this is a managed switch. Okay, and then we said now enable mode will bring us to privilege mode. Now we have to further go to global config mode by typing config terminal. Right, now that we are on a global config mode, we can be able to configure that this device, or we can be able to show or print any information on this device. related to this device, or either related to the ports on this device, right? So basically, let's start by these two devices. I want to see the interface of fast01. Remember, this is not case sensitive, just in case if you see me typing this in bold. So I want to see the information of fast Ethernet 01. So what I'll do is I'll just type in do show interface fast01, because now I'm willing to see the information of whatever that is happening on that interface. This will be able to tell me what's going on with the interface. For now, I can see that the interface is up. As you can see, we have a green triangular shapes in there. Otherwise, if the interface was down, it was gonna show us red. All right. So also what I can see the MAC address of that port, which is the port on the switch. Okay, because each port on the switch have its different MAC address, and then I can also see that this is the bandwidth that we have, and then I can also see that the transfer load is 1 of 2255, and then I can also see that the duplex mode here is set to full. All right, and then I can also see that the speed is 100 megabits per second. All right, this is all I wanted to see at the moment. And then we can also, as we move along, we will talk about queues, which is the first in first out. This is a queue type, first in first out, but for now we are focusing on this speed and duplex. All right, so speed simply means that the rate at which the data is transferred between two or more devices on the network, right? And then as we move along, we will talk also about the CRCs and overrun, and we also are gonna talk about broadcasting and so on, right? And dribbles. All right, let me just minimize this for now. Let's go to the network interface card of the PC itself. So if I go to desktop, in this case I'm using a Cisco packet tracer, but if you're using the computer, the real life computer, I'll show you also how to navigate to these configurations. All right, so if you go to desktop and go to IP configuration, you will be able to navigate to configuration and go to the interfaces, go to fast Ethernet 01, which is this one. All right, closer to the PC. Well, as you can see, we have a duplex here, and then also we have a bandwidth. All right, and then we have a media access control, which is our MAC address. So currently, as you can see, these computers, they are by default on auto negotiation. They are set to auto. Right, if I can untick this box, because the switch is on a different mode, let's see what's gonna happen. The link automatically becomes down, and the switch will generate the message which tells us that the link is just down. Okay, because now there is something called a mismatch, right? A speed mismatch. Okay, there is a speed mismatch. So if I put it back to auto, as you can see what's going on the interface, you will see that the link just turns up. Right, now what happened with the speed, or what happened if I put it to half duplex? As you can see now, the interface just went up. Right, of the PC, the mode is set to half duplex, which means it can only send. And then on the interface on the switch, it's just have the different mode set on or configured. It's set to duplex full, which means it can send and receive at the same time. Alright, now let me just hook this interface up again by typing the command either auto. As you can see, auto will hook the interface up. Right, and also I can also say duplex half to match the same duplex mode between the two. Alright, as you can see, the interface is still up. However, if I can try to change it to full, the interface will just go down. Right, as you can see, the interface just went down. Right, now let me put it back to auto so that it's gonna decide for us the best duplex mode. Alright, so what about speed now? To configure the speed, you just type in speed and then you type in the number of the speed. Okay, so if I go to do show interface FA01, I'll be able to see that the speed currently that the interface is running on is this one until I modify it. So if I click on it, as you can see now, the speed is just different. It's no longer the same, so there is a speed mismatch. That's why the link is just down. Right, so if I go to do show interface faster than 01, I'll be able to see that now the speed has changed. It's no longer the same. The speed is in 10 megabits per second. Alright, and then also the interface is down, so I'm expecting to see that the status of the interface is down. Alright, line protocol is also disabled and down. Okay, I can hook this up by saying auto. As you can see, the interface is just down. I mean, it's just up. It was down, but then now it's up. Alright, okay, now what is an MTU? MTU stands for maximum transmission unit. This simply means that it tells us the largest data packet size that two connected devices on the network can accept. Right, so let me just come in here and do interface FA01. Right, and then I'll say do show interface FA0/1. Right, oh okay, so the MTU is 1 or 1500 bytes. Okay, it's supposed it is 1500 or it's 1500 bytes. Now, what is the giant? A giant is one of those packets that exceed the limit MTU. Okay, which means the packet that is larger than 1500 or 1500 bytes. Right, the one that is larger than 1518. Alright, so basically, what about runs? The run simply means that whichever packet that is less than 64 bytes, that is what we call as runs. Alright, now there is also, if you pay attention, there is also something called CRC. This stands for cyclic redundancy check, which is used to determine or detect the data that is giving errors on the data transmission. Alright, between the devices on the network. So there is also overrun, and then there is also ignored, and there is also input errors. We don't have any collision we only have like 10 interface resets. That tells us how many times the interface was up and down, up and down, up and down, right? Okay, I hope this video was so informative to you. Make sure that you like, share and subscribe to Wi-Fi Tech Lab channel. Hopefully on an upcoming video we just gonna bring you the topic based on how to configure the spinning tree protocol, how to configure the LACP, which is part of the layer 2 ether channels, and also how to configure PAGP protocol, and also we will also talk about more based on securing the device itself. We will talk about the switch ports, and we will talk about how to shard the links that are not used, and then we'll also see if we can touch upon some VLANs. And yeah, let's meet again on the next upcoming video. Okay.